Hi everyone, today we're going to do further trigonometric identities and sums and differences of angles. But first we're going to prove cos A minus B equals cos A cos B plus sine A sine B. Now first we need unit circle. Okay, so rough unit circle right there, and it has a point P and Q. Now coordinates of P is cos B sine B, and Q is cos A sine B. No, sine A. Sine A. Okay, so we got that coordinates sorted. Now, if P is on the angle B, like that's BB there, and then Q is on the angle A, what will be the in-between angle? What will be the between angle? It will be A minus B, wouldn't it? Yep, A minus B. So how am I going to prove this with the unit circle this? So I'm going to use two formulas and equating it. So first formula is distance formula of the PQ, okay? And then I will use the cosine rule, finding an unknown side, which is the PQ. And then I will equate them. And I'll change that, make the cos A minus B the subject. And then it'll be cos A cos B plus sine B and sine B. Yeah, sine A and sine B. So we will see. Let's have a look at distance formula with PQ. So distance formula by using the distance formula. Okay, so does anyone remember distance formula? D square equals x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's what I'm going to do. I'm going to call this one as PQ, so that's my x1, y1, that's my x2, y2. Okay, so hopefully you remembered it. And I'm going to go PQ square equals cos A minus cos B squared plus sine A minus sine B squared. Okay, and I'm going to expand this one because it's a perfect square. Cos square A minus 2 cos A cos B plus cos square B plus, I'm going to expand this one, then I'm going to put something underneath, sine square A minus 2 sine A sine B plus, I don't know whether you can see it, sine, I'll write it really small, go B. Now here we got some interesting things happening here, just underline that. If I do cos square A plus sine square A, this will become 1. Remember the identity? Sine square theta plus cos square theta equals 1. So that becomes 1. And same thing happens here. Sine square B plus cos square B is 1. So what happens now is 1 plus 1 minus 2, because that's common factor. And I'm going to put these ones in. So it'll be cos A cos B plus, because I'm taking minus out, so it'll be plus sine A sine B. Okay, so what happens now is I'm just PQ square is 2 minus 2 cos A cos B plus sine A sine B. Now I'm going to call that as 1. So we use the distance formula here. Now what I'm going to use now is cosine rule. By using the cosine rule. So I'm going to go PQ square equals, here, this is a triangle I'm looking at. okay? And PQ is the one I want to find out. So it's opposite angle I have to use. Now remember, this is unit circle, so the side that I have to square it is 1, okay? So it'll be 1 square plus 1 square minus 2, 1 times 1 is cos A minus B, okay? So that looks pretty familiar. So I'm going to go PQ, oops, I'm going to tighten it up. PQ equals 2 minus 2 cos A minus B. And I'm going to make this one 2. So can you see that PQ square, PQ square? So I'm going to equate them. So let's have a look. So what I'm going to do here is 2 minus 2 cos A minus B is equal to 2 minus 2 cos A cos B plus sine A sine B. Okay, and you know that that's same, has to be same as that because they're all the same anyway. So therefore cos A minus B equals cos A cos B plus sine A sine B. Excellent, so we got that. Okay, so we proved it. That's good. Now, how are we going to do with cos now? Cos A plus B. I'll have to use this, and I'm going to change this one into A minus B. So what happens is, instead of B, I'm going to put minus B in there. That becomes A plus B. So instead of B here, I'm going to put minus B there, okay? So therefore cos A minus B, which is, I can write it as A plus B, equals cos A cos minus B plus sine A sine minus B, okay? Now this is odd, even function, that's odd. Now what happens here, if you just look at the curve wave, so what is it? Cos is like this, and if you reflect it by y-axis, if you fold it up, it'll match up, which means it's even function, okay? The same thing, like if I put this line there, doesn't really matter whether you get negative x values or positive x values, you get positive y values, okay? So do you remember this? When you put negative value, even function, it comes out as a positive, okay? So this becomes cos B. Now sine is like this, yeah? And so other side will be like that, okay? So it does, like, it's when it's positive, it's negative, negative, positive, so it's opposite. So what happens with negative function? You put it in minus, so that's even function. So the sine will be even function. So my final formula is cos A cos B, because it doesn't really matter. Now this becomes sine A is minus sine B. So this minus will go out there. So finally cos A plus B equals cos A cos B minus sine A sine B. So that's my formula right there. Okay, so we got cos A minus B, formula there, cos A plus B. Excellent. So you might say, what happens, miss? What happens is a sine A plus B. What happens to that then? Now what we're going to do is we're going to substitute 90 degrees take away A into 4A. We're still going to use this original that we've started. So let's have a look. So if I put cos A minus B, cos A minus B, I'm going to put, instead of A, I'm going to put 90 minus A in there. Minus B equals. So instead of A, I'm going to put all of them here. I'm going to put 90 minus A. So let's go. Cos 90 minus A and cos B plus sine 90 minus A sine B. Okay, so that's not too bad. Now what we are using here is complementary angle, guys. So it'd be cos 90 minus theta is sine theta. Okay, and same thing as sine 90 minus theta equals cos theta. Okay, if you didn't know, please memorize that. So I'm going to tie this one up. So what happens with here, I'm going to go cos 90 minus A plus B. Now can you see what I've done there? You can actually change that, isn't it? We can manipulate this, and then this becomes my sine A, just like this one. Okay, and then cos B plus that becomes cos A and sine B. And then, oh, that's not it, because that we have to change it. So this one is same as this, isn't it? So therefore I can say sine A plus B equals sine A cos B plus cos A sine B. So that's what we got. Phew! All right. Now we have to change. What about sine A minus B? A minus B is easy. Why? I'm just going to do, what I'm going to do is A minus B, and that will give me A plus B, yeah? So I'm going to put all the B minus in there. So sine A cos minus B plus cos A sine minus B. Okay, so this whole thing will become sine, plus there. And that will be A minus B, yeah? Because we want to just substitute the minus B in there here. Excellent. Ooh, I don't want to make mistake here. We've gone so far, we're nearly done. And this one is what? It's even function. So sine A, we don't care about the negative, becomes positive there. But this one is odd function, so negative comes out to the front. So because A sine B. So the answer is this. So we got sine A minus B as a sine A cos B minus cos A sine B. Now only thing you just have to remember, sine is easy because it's a plus, minus is minus. But cos is a little bit different. It's a minus, it's a plus. And if it's a plus, it's minus. Okay? Well done, people.